This video demonstrates how to calculate the cost for a particular layout. This is very similar to your homework assignment 9.4. This is actually 9.5. So I mislabeled it here. 9.5 is the data I'm using. Now, unlike the homework assignment that you have from 9.4, where you have kind of a two-dimensional layout, and that you have the ability to arrange the 6 departments horizontally and vertically. Here it's a little bit easier in the sense that I only have the one dimension. I just have these 4 tables, table A, B, C, and D, and each of these tables are 30 feet apart. And so we're going to evaluate this based on assigning each of these activities to one of these tables. And so based on this, we're going to just put them in order. So table A will be picking up forms, table B will be advising, table C will be picking up your class cards, and D will be payment or verification. And so we will evaluate the cost associated with that. Now, they don't give us a cost, but they do give us a distance. They say it's 30 feet in between each of these tables. And so we can use distance as a substitution for cost. The greater the distance, the more expensive or costly would be the layout. And even if they weren't to give us distance, so if they don't give you cost or distance, then you can simply build your own scale. So everything from A to B would be 1, A to C would be 2, and A to D would be 3. We would just count the number of tables that it would have to move, or the number of departments. Now, the first thing we have to do is they show us the relationship between these activities. So between picking up forms and advising, there is 450. Picking up forms and class cards, there is 550. So these are the interactions between these activities. And picking up forms and verification, there's 50. Now, going the other way, advising back to pick up forms is 350. And then, of course, there seems to be no interaction. So this is a very simplified set of data. But the first thing you have to do in all cases is we don't care which direction it's going, whether it's going from A to B or B to A. We just need to know the sum total. And so the sum total in this case would be 800. 450 plus 350 gives you 800. So I'm going to just change this. I'm basically going to collapse half the table. Now, of course, we have the other ones here. So this idea of forms to class cards is 550, but there is no class cards back to forms. And so the rest of these numbers are 0. So we'll just blank those out to let us know that we have done our job in that regard. Looks like I'm missing a set of data here. Oh, 750 is that. So there was no, so it looks like for the most part this is kind of a one-directional, except there was a little bit of interaction from advising back to picking up forms. And so we combine those, but in regards to the other interaction, there was additional 0. So now we know that it once again doesn't matter which direction they're going from A to B or B to A, or C to D or D to C. We've just combined those to figure out the overall interaction. Now we can actually figure this out. Now, what I've done here is I basically have determined all of the possible. So things can go from A to B, A to C, A to D, and then we look at B. Of course, I've already acknowledged the A to B, so now we're looking at B to C, B to D, and then we go on and we got, once again, you're recognizing any of the new, so C to D. I've acknowledged all of the movements from D to A or D to B or D to C. They've already been covered in these other options here. And so let's go ahead and put in the distance. This is where we put in the cost or our own scale if they didn't give you the distance cost. So A to B we know is 30. A to C is 60 because we're going 2 tables, so 30 and then another 30. and then A to D is then 90 feet. B to C is back to 30. We've already addressed the A to B or B to A, so we only have to do the B to C, and then the C to D, or I'm sorry, B to D is 60, and then C to D is 30. So we've acknowledged all the possible movements, and now it's just a matter of plugging in the amount. So here we have A to B was this 800. I'm going to just reference this equals the 800. So A to B. And remember the idea that we combine the B to A and the A to B together, and so 800. So it doesn't matter which direction it's going. We have the A to C is then the 550, and the A to D is then 50 there. This is then the B to C. There's 200 forms of activity. We will put this in here. There is 0 actually, so there is no interaction between advising and verification at all. And then we have the last relationship, the C to D, so class cards to verification. There's 750 interaction there. And so we can simply add these up. So we would take this and multiply it times the activity. And we're going to go ahead and copy this down. And then we'll put in the sum here of this. So the total amount of distance in regards to this model is 90,000 is what we're looking at in regards to that. Now let's look and see if we can improve this layout to some degree and see if there is an improvement we can make. Part of this, I think one of the easiest way to do that is to kind of acknowledge the big interactions. We have a lot of interaction between A and B here of 800. We also have a lot of interaction of C and D of 750. But A to C is 550. But if you look at the interaction between C and B, there's only 200. And so we might be better off moving those. Now, however, we also run into an issue here where we want to keep C and D together. But so let's play around with this. Let's say if we were to rearrange this and go with a layout of, so we're going to put advising first here. Here's where you have to be a little creative. So we're going to put advising first, and then we're going to put the picking up the forms. Oops. We'll put the picking up of forms at the second table here, and the class cards will stay at C, and this will stay at D. So let's see if this arrangement is a little bit better in regards to our layout. And so what we're going to do is I'm going to copy this over again here. So Control C, and we're going to evaluate this new plan here. Control so now we got to change these around. A to B is now, it's still 30 feet because they're next to you, but A to C is now 30 instead of being 60. And so A to D is 60 instead of 90, so that's closer. B to C, we've spread those out. B to C is now going to be 60, and B to D is going to be the 90, and C to D will be the 30, so it stayed the same. So we've moved some things around, and so we've increased the distance, but hopefully now if we go back, if you look at the A to B here, we still have the 800, But the A to C, so the A to C is the 550. Now we've moved those closer than we had up above. So I want to point this out to you. You'll see that this 550, because they were two tables apart, was 60, but now they're only 30 because we flipped A and B. A to D, A to D is 50. So we gain something there a little bit. Instead of being 90 feet apart, they're only 60 feet apart, but there's only 50 there. So there's not a whole lot there. The B to C, is 200. Now we move them a little further apart. Instead of 30, it's now 60. But the trade-off is we're getting a lot more. So we moved, B and C apart because we flipped A and B, but we're going to gain something here, as you'll see shortly. B to D is still zero. So even though that went to 90, it doesn't hurt us a whole lot because there was zero interaction. So B can be a long ways away from D. And C to D, we maintained that relationship. We kept C and D right next to each other because that was 750. So we're hoping that we'll gain something here. So once again, you take this, you times the distance, times the interaction. So we'll copy that down. That stayed the same. But you'll see that when we total this up here, the total distance will be much shorter. And so we will have gained an advantage here. So we went from 90,000 feet down to 78,000 feet. So by just flipping those two tables, but all of it is based on the interaction. And so once again, the idea of this technique is that you want to identify, once again, the total interaction. It doesn't matter which direction it's going, but the interaction between the various activities or departments or workstations. So what is the sum total of that activity? It doesn't matter if it's going from A to B or B to A. What's the sum total? And then the object is to try and lay it out in such a way that we minimize the distance or the cost. So if we had a certain amount of cost associated with every foot, in this case we didn't have that, we just had the feet. Or you could even end up with, if they even didn't give you that, just the number of tables you would have to move over. So you could create the scale yourself. But if you think there is a better way to lay it out, you can make that change and recalculate the cost or the distance. The one with a lower amount is the better design. In this case, we would go with the secondary one of 78,000. That's a much better improvement over the original layout and its cost.